Specification for telephone systems Part 1. General technical requirements. The telephone system expansion shall extend reliable voice communication to a wide network of new buildings, process clusters, substations, operator shelters, and remote wells. These services shall be integrated into the existing main PX system, which is based on the NEC NEX 2400 IPX platform, currently operational at the central control room. The design shall prioritize seamless integration, service continuity, environmental robustness, and compliance with established telecommunication and electrical standards. The telephone services to new locations, including operator shelters, ITR buildings, substations, and remote well sites, shall be provided through both analog and VoIP technologies. Analog services shall be extended through structured copper cabling, terminated at a secondary MDF main distribution frame, while VoIP services shall operate over a dedicated voice LAN integrated with the existing SDH network. All deployments shall ensure full coverage and high availability through proper routing, VLAN configuration, and structured cabling. A minimum of 70 analog extension lines and 40 VoIP lines shall be provided to fulfill the communication needs of the expanded facilities. Analog lines will be routed from the existing PBX system via copper cables and terminated on a newly installed wall-mounted secondary MDF in the telecom room. VoIP lines shall be provisioned using a new PoE-enabled Ethernet switch connected to the facility's core Layer 3 Ethernet switch, enabling full IP telephony across the network. The secondary MDF shall include Crone-type cross-connect blocks with adequate spare capacity, minimum 10%, and be equipped with IDC, insulation displacement connection type terminals. 2 100-pair blocks will be used, one for PBX extension line terminations and another for digital E1 circuits from the SDH MUX. All terminations must be neatly labeled, fully documented, and installed in compliance with structured cabling standards. For field communication, outdoor explosion-proof telephones housed in acoustic booths shall be installed at strategic process areas and cluster locations. These telephones must be EXD certified for Zone 1 environments, Gas Group 2B, T3, comply with IP66 ingress protection standards, and be paired with audible visual alerting units. They must be monitored from the central PBX system and be powered by a local 240-volt UPS with 8-hour autonomy, ensuring functionality during power disruptions. Indoor communication facilities in new buildings, e.g. substations, ITR buildings, and shelters, shall be equipped with both analog and IP telephone sets. Analog sets shall be cabled from the MDF using 10-pair copper cables terminated on wall-mounted IDF cabinets fitted with 50-pair 110-type blocks. VoIP telephones shall draw both power and connectivity via a PoE Ethernet switch installed in the office and voice LAN rack, with uplink to the core switch verified for throughput and VLAN integrity. At remote well sites and distant clusters, a telephone line extender multiplexer shall be deployed to extend analog services over the SDH network, avoiding the need for long copper runs. VoIP connectivity shall similarly be extended through the SDH MUX using IP routing protocols. A small local Layer 2 PoE switch shall distribute VoIP services within each cluster or well site, ensuring each ITR location is equipped with a standard allocation of 5 telephone outlets, 3 VoIP and 2 analog. All cabling infrastructure shall be Cat6 or higher, fully VoIP ready, and comply with structured cabling standards. Horizontal cabling from distribution frames to endpoint outlets must be documented with detailed drawings including riser diagrams, rack elevations, and labeling schemes. Cable trays, conduits, and penetrations must be properly sealed and grounded to ensure signal integrity and electromagnetic compatibility, EMC. Numbering plans for analog and VoIP extensions shall be harmonized with the existing dialing plan to maintain uniformity across the entire telephony network. The expansion shall leverage the current dialing scheme for route access, internal extension dialing, and public network interconnects via E1 trunk interfaces. Final configurations shall be programmed into the PBX and documented as part of the system handover. The expansion must not compromise existing services and shall be fully reversible in case of configuration rollback. Specification for telephone systems Part 2. System requirements and equipment specifications. A new wall-mounted vertical or secondary main distribution frame MDF shall be installed within the telecom room of the control building, fully dated to the expansion scope. The MDF must be designed using IDC-type test and disconnect modules to ensure ease of maintenance and future expansion. It shall be fabricated from flame-retardant materials with clear separation between telecommunications earth and electrical chassis earth. All pairs, active or spare, shall be terminated and labeled to facilitate operational traceability and system integrity. Each MDF shall be fitted with jumper rings or cable management rails to support organized and accessible patching. Termination blocks must use 0.9 mm twisted pair annealed copper conductors with halogen-free insulation. Jumper wires shall be routed in parallel with the terminal blocks, and all connection modules shall be testable without full circuit disruption. Proper earthing of the telecommunication bar is required with insulated mounting to avoid interference and ground loops. Intermediate distribution frames, IDFs, must be installed in each operator shelter, ITR, and substation. The IDFs shall be enclosed in wall-mounted telephone cabinets sized 600 by 300 by 300 millimeters and must include 50 pair 110 type connecting blocks. These IDFs will terminate the 10-pair copper interbuilding cables running from the main MDF. All terminations must be tested, labeled, and documented, and the cabinets must provide room for future expansion. The VoIP telephone system shall be powered and supported by a Layer 2 PoE Ethernet switch, which shall be connected to a central Layer 3 core Ethernet switch in the telecom room. This switch will serve both the IP phones and the office PCs via a shared RJ45 port supporting IEEE 802.3AF PoE. It shall support VLAN tagging, IEEE 8021Q, full QoS enforcement, and operate under both static and DHCP IP schemes. The configuration shall include support for SIP and H.323 protocols, enabling flexible integration with both legacy and modern IP PBX systems. IP telephones shall be selected to offer enterprise-level features, including call transfer, call forwarding, three-way conferencing, directory lookup, redial, hold resume, volume control, and visual message indicators. Phones must be equipped with LCD displays, programmable speed dial buttons, and integrated RJ45 interfaces for data pass-through to co-located PCs. For larger conference rooms, IP conference phones shall provide 360 degrees audio pickup, full duplex communication, a minimum SPL of 80 dB at 0.5 meters. All external telephones shall be explosion-proof and weatherproof, EXD certified Zone 1 IIB T3 with IP66 ingress protection. They shall be installed inside corrosion-resistant GRP acoustic booths mounted on steel pedestals. Each booth shall be painted in high-visibility yellow or orange and lined with sound-absorbing material, offering a minimum 15 dB attenuation at 1000 Hz. The telephone units must be equipped with noise-canceling microphones, robust stainless steel keypads, recall and LND buttons, and tamper-resistant cable terminations. Each outdoor telephone booth shall include a white explosion-proof flashing light and a sounder. The light shall activate upon incoming call ring signal and be powered from 240 VAC. It must feature a 15-joule flash with 60 flashes per minute, designed for visibility across process zones. The sounder shall emit a minimum of 105 dBA at 1 meter and be synchronized with the call ring signal. It shall be independently certified for use in Zone 1 explosive atmospheres and housed in IP65 rated GRP enclosures. Power to all field telephones and acoustic booths shall be supplied from a local redundant UPS system 240 VAC 50 Hz with a minimum of 8 hours autonomy. All field units shall be hardwired to their power sources and protected with circuit breakers and surge protection. Where field UPS is unavailable, contractor shall supply a dedicated power converter or backup power module to ensure operational continuity. The telephone system shall be monitored and maintained through the existing PBX system. All analog extensions shall be routed through PBX line cards and assigned with dialing numbers as per the project's approved scheme. All IP telephones shall register via the existing VoIP LAN infrastructure and interconnect to the PSTN or internal network using SDH E1 trunk interfaces. The entire system shall be configured, tested, and commissioned in coordination with the existing control systems to ensure uninterrupted voice communication during and after project execution. Specification for telephone systems, Part 3, Equipment, Connectivity, and Integration Requirements. The analog telephone extension shall originate from the existing NEC NEX 2400PX PBX system and be terminated on the newly provided wall-mounted secondary MDF. The MDF must include two 100-pair Krone-type IDC blocks, one allocated for PBX line extensions and the other for interfacing E1 digital circuits. All copper pairs shall be routed through underground conduits or duct banks, ensuring physical protection and electromagnetic separation from power lines and other sensitive signal cabling. Telephone line equipment cards and digital facility interface DFI cards shall be added to the existing PHABX to accommodate the additional analog and IP trunks. These interface cards must support both subscriber line signaling and E1 bearer circuits to SDH multiplexer tributaries. All interface parameters, timing, signaling, clock synchronization must be programmed in compliance with existing telecom configurations and integrated seamlessly with the SDH transport network for PSTN access. A telephone line extender multiplexer shall be provided to carry analog signals over fiber where physical copper runs are not feasible due to distance. The system shall utilize SDH transport channels and support at least 4 to 8 telephone lines per multiplexer. These units shall be deployed at the control building and remote sites, terminating to analog telephone handsets via structured copper cabling. Each multiplexer must be powered by the same UPS infrastructure used for telecom equipment and include auto recovery capability upon signal loss. Each building and shelter receiving telephone service must be equipped with a compact wall-mounted IDF cabinet with internal 50-pair connecting blocks. A minimum of one analog and one IP telephone outlet shall be provided per location, unless additional units are explicitly required by the user area classification. These cabinets must be designed to allow future expansion, include lockable doors, and provide basic protection against dust and moisture intrusion. The VoIP network design shall be based on a dual-layer topology. Layer 2 PoE switches shall be installed in each ITR and shelter to provide last-mile connectivity to IP handsets. These switches must be configured with VLAN IDs, QoS settings, and storm control mechanisms as per telecom standards. Uplink from these access switches to the Layer 3 core switch must be via 100 Mbps fiber Ethernet channels integrated into the SDH network through Ethernet interface adapter cards. Each remote cluster and well shall be provisioned with 5 telephone outlets, 3 RJ45 VoIP, and 2 two-wire analog ports. These shall be installed using horizontal cabling designed for Cat6 performance, fully certified and labeled. Patch panels shall be installed in each cabinet to terminate the structured cabling and provide connection flexibility for endpoint equipment. All patch cords shall be factory certified, flame retardant, and RoHS compliant. To support VoIP service continuity, every LAN switch shall be connected to the local redundant UPS system. The design must ensure that both access and core switches continue to operate in the event of a power outage. The contractor shall confirm that all existing SDH nodes, interface cards, and L3 switches are capable of handling the added traffic without degradation of service or network bottlenecks. Every VoIP endpoint shall support both static and DHCP-assigned IP configurations. The system shall provide options for remote provisioning via TFTP or HTTP configuration servers. IP handsets must support SIP and H.323 protocols, enabling interoperability with existing and future PBX platforms. Voice compression, jitter buffering, and echo cancellation features shall be enabled by default and verified during configuration testing. The dial plan across all analog and IP handsets must align with the existing site-wide numbering scheme. Internal and external call routing, intersite extensions, and PSTN access must be configured according to pre-approved dialing policies. The contractor shall submit a complete dial plan matrix detailing extension numbers, device types, user assignments, and call routing tables for review and approval prior to commissioning. Any changes to existing numbering blocks must be approved by the system owner. TRUS specification for telephone systems, Part 4. Performance, monitoring, and field equipment standards. The telephone system must ensure uninterrupted communication in both routine and emergency scenarios. Analog and VoIP handsets deployed at process units, remote wells, and control points must be continuously monitored via the PBX and LAN management systems. Devices shall support remote diagnostics, allowing for centralized fault detection and status monitoring. Any interruption in connectivity, power, or hardware fault must trigger visual and audible alerts at the monitoring station. All outdoor telephones must meet strict environmental performance requirements. Each telephone unit shall be housed inside a weatherproof, corrosion-resistant acoustic booth constructed of glass fiber reinforced polyester, GRP. The booths shall attenuate at least 10 dB at 200 Hz, 15 dB at 1000 Hz, and 15 dB at 4000 Hz, reducing ambient noise in high decibel environments such as compressor areas or flare zones. The lining material shall be non-flammable, non-hygroscopic, and anti-static. The explosion-proof outdoor phones shall be EXD certified for Zone 1 hazardous areas and feature ingress protection not less than IP66. These devices must withstand temperatures from -10 degrees Celsius to 60 degrees Celsius, be UV resistant, and capable of surviving 85 degrees Celsius surface temperatures in direct sunlight. The keypad must be stainless steel, dirt-repelling, and resistant to abrasion, with engraved digits rated for at least 10 years of outdoor use without fading. Each outdoor booth shall include a flashing beacon and a sounder unit. The beacon shall have a white lens, operate on 240 volts AC, and be visible from all directions. It must be integrated with the telephone's ring circuit and flash automatically during incoming calls. Flash energy shall be rated at 15 joules with a minimum of 60 flashes per minute. The sounder must emit at least 105 dBA SPL at 1 meter and be triggered simultaneously with the visual alert. Both beacon and sounder shall be certified for explosive atmospheres and bonded to earth. Field telephones must include a robust dynamic microphone with an integrated amplifier and noise cancellation circuitry. The handset cord shall be reinforced with braided steel with a minimum tensile strength of 1600 N. Each handset shall be fitted with LND, last number dialed, and recall buttons, and allow adjustable flash timing from 80 milliseconds to 250 milliseconds. Ringer signal compatibility must range from 15 Hz to 68 Hz. Devices must support tone dialing via DTMF and be configurable for abbreviated dialing memory. The complete outdoor telephone station, comprising handset, booth, beacon, and sounder, shall be pedestal mounted on a steel stanchion securely anchored to a concrete base. All wiring must be enclosed in flame-retardant, UV-stable conduit with stainless steel glands and junction boxes. Cabling shall be 6-pair UV-rated copper terminated in designated terminal blocks within the nearest field enclosure or telecom junction box. Power supply for each outdoor station shall be derived from local 240-volt AC redundant UPS sources. The power system must support at least 8 hours of autonomous operation under full load. Circuit protection shall include miniature circuit breakers and lightning surge suppressors. In locations where standard UPS is not available, contractor shall install a dedicated power converter with battery backup housed in a weatherproof enclosure. Outdoor stations shall be integrated with the PBX to allow for proactive testing and fault detection. The system must report the status of each terminal, active, idle, faulted, or disconnected, to a centralized management interface. This functionality may be implemented through the line extender multiplexer or via SNMP-compatible monitoring tools, depending on the system architecture. All field equipment, including booths, telephones, beacons, sounders, and power modules, shall be fully certified for installation in explosive gas atmospheres, Zone 1 IEB T3. Certificates of conformity, along with type test reports and datasheets, must be provided for every device. Labels must be clearly engraved and permanently affixed to each unit, indicating model number, certification type, IP rating, and electrical ratings in accordance with applicable IEC and ATEX standards. Specification for telephone systems, Part 5. Inspection and testing. All telephone system components, subsystems, and cabling infrastructure shall be subjected to rigorous inspection and testing to ensure compliance with technical specifications, functional reliability, environmental performance, and applicable safety standards. Inspection and testing activities shall be executed under a controlled QA/QC plan, which shall be submitted by the vendor and approved prior to any fabrication or assembly. No shipment or site installation shall occur until factory acceptance tests, FAT, have been completed, documented, and formally accepted. The factory acceptance test, FAT, shall be conducted at the vendor's premises and include full system assembly of representative units. FAT shall be carried out on complete, fully integrated telephone system modules, not on individual components. The vendor shall develop a comprehensive FAT procedure covering visual inspection, electrical conformance, functional testing, and verification of auxiliary features such as alarm activation, beacon flashing, and interface response. This FAT procedure must be submitted to the EPC contractor and project owner for approval at least 30 days before testing begins. FAT shall be scheduled with a minimum of 14 days notice and witnessed by authorized representatives of the EPC contractor and the end user. The FAT shall demonstrate compliance with project-specific configurations, response to PBX integration, IP telephony behavior under VLAN conditions, and simulated field conditions. Tests shall include dialing plan verification, power consumption under normal and backup power, beacon sounder response, and VoIP registration. Deviation from test plan parameters shall require immediate rectification and retesting. Punch list items generated during FAT shall be compiled into a formal report and submitted within 7 days of test completion. This list shall include all nonconformities, functional issues, hardware damage, or incomplete configurations. The vendor shall address all listed items at their cost, with corrections witnessed by the EPC contractor and validated prior to final packaging and shipment. No partial approvals or deferred corrections shall be accepted unless formally agreed upon by the client. All FAT results shall be documented, signed by witnesses, and entered into the system's design dossier. The design dossier must include signed FAT forms, equipment configuration sheets, wiring diagrams, PBX interface maps, IP address registers, and voice VLAN test logs. These documents shall be included in the final handover package and form the basis for site acceptance and commissioning clearance. Upon delivery and installation, a site acceptance test, SAT, shall be carried out for each subsystem, including indoor and outdoor telephones, MDF, IDF cabinets, VoIP switches, and PBX extensions. SAT shall confirm end-to-end operability, field equipment integrity, signal clarity, dialing functionality, and integration with existing telecom infrastructure. All devices shall be verified for physical condition, correct labeling, correct termination, and operational readiness. SAT procedures must be submitted and approved 30 days before commencement of tests. The SAT shall be witnessed by the EPC contractor and client's representatives. Each device and connection point must be tested for proper function, including analog line audio clarity, IP phone registration, power over Ethernet draw, speakerphone quality, and responsiveness of visual audible indicators. Special emphasis shall be placed on outdoor phones, ensuring sounders activate during ring cycles and beacons are visible from 360 degrees. Performance under UPS backup must be demonstrated where applicable. As with FAT, any defects, failures, or incomplete items during SAT shall be logged in a punch list and addressed promptly. Full rectification must occur before commissioning is permitted. Once all punch items are cleared, signed approval shall be required from the EPC contractor and end user. SAT reports must include before and after punch list status, inspection forms, power-up records, photo logs, and verification of dialing plans in active mode. All inspection and test documentation, both FAT-SA, must be compiled into the final handover quality dossier. This dossier shall include the complete ITP, signed checklists, certificate of conformity, calibration reports for all instruments used, and final system readiness certification. The documentation shall be indexed, digitally stored, and submitted in both editable and locked formats. No part of the telephone system shall be deemed complete or handed over until these tests are successfully concluded and approved.